Clair Patterson was trying to measure the age of the Earth. But every sample he touched contained far more lead than it should. The numbers were impossible. The contamination followed him from room to room. He thought his experiment was broken. It was actually telling him something much larger. Modern civilization had covered the world in poison. Patterson grew up in Mitchellville, Iowa, the son of a postal worker and a mother who served on the local school board. A chemistry set she gave him began an obsession with understanding what matter was made of. During the Second World War, Clair and his wife Lorna joined the Manhattan Project. At Oak Ridge, Tennessee, he worked around the machines that separated uranium and learned to use a mass spectrometer, an instrument capable of distinguishing atoms by their mass. After the war, that knowledge carried him to the University of Chicago. There, geochemist Harrison Brown offered him a problem that sounded almost impossible: measure tiny quantities of lead inside meteorites and use their isotopes to determine when the solar system formed. If Patterson could do that, he might calculate the age of the Earth itself. He began in 1948 in Kent Hall, one of the university's oldest buildings. The laboratory was dusty. The glassware, reagents, and air all contained traces of lead. For ordinary chemistry, those traces would have meant almost nothing. For Patterson's samples, they overwhelmed the signal he needed. He scrubbed equipment. He purified chemicals. He sealed samples and changed containers. Still, the lead returned. The work took years longer than anyone expected. When Brown moved to the California Institute of Technology, Patterson followed. He designed a laboratory unlike almost anything then in existence. Filtered air, fiercely cleaned surfaces, and procedures built around the assumption that contamination could come from anywhere. Only then could he hear the signal beneath the noise. Patterson analyzed primordial lead from the Canyon Diablo meteorite, material formed with the early solar system. In 1953, the numbers finally aligned. The Earth was about 4.5 billion years old. He refined the figure to 4.55 billion years and published it in 1956. The estimate was so good that modern measurements have barely changed the answer. Patterson had completed one of the most important measurements in science. But the lead that had sabotaged his laboratory had left him with another question. Why was it everywhere? His new techniques allowed him to measure lead in ordinary rocks, sediments, and seawater. The pattern made no sense as a natural cycle. Deep ocean water contained far less lead than water near the surface. If the source were ancient geology, the distribution should not have looked like that. The surface was being contaminated recently. Every day, motor vehicles burned petrol containing tetraethyl lead. The additive reduced engine knock, but the lead did not disappear. It left exhaust pipes as microscopic particles and settled into air, dust, soil, and water. The contamination Patterson had fought inside his laboratory was a fingerprint of industrial society. In 1965, he published a paper called Contaminated and Natural Lead Environments of Man. Its argument attacked a comfortable assumption. Scientists often describe the amount of lead found in modern people as normal. Patterson said normal was not the same as natural. The accepted baseline had been measured in a contaminated world using contaminated laboratories. From ancient bones, deep water, and polar snow, he reconstructed a cleaner past. He estimated that many Americans carried more than 100 times the natural concentration of lead in their blood. The response was immediate and hostile. Robert Kehoe, the country's leading authority on industrial lead exposure and a consultant to the lead industry, called Patterson more zealot than scientist. Another toxicologist dismissed his work as rabble-rousing. Powerful institutions preferred a simple rule. Unless clear poisoning symptoms appeared, exposure was acceptable. Patterson rejected the premise. The absence of collapse did not prove the absence of harm. He did not enjoy becoming a public campaigner. In private, he wrote that the fight had taken him away from the basic research he loved. But he kept going. He wrote to California's governor. He testified in Washington. He criticized the closeness between public health agencies and the industries they were meant to judge. He carried clean equipment to Greenland and Antarctica. The layers of snow preserved a history of the atmosphere, showing lead rising dramatically with industrialization and the age of the motor car. He compared ancient Peruvian bones with modern human tissue. The difference was not subtle. Industrial lead had entered the body on a scale natural geology could not explain. In 1971, a National Research Council panel examining airborne lead excluded Patterson, even though he had become one of the world's leading experts. His evidence was largely ignored. 2 years later, the United States Environmental Protection Agency announced the beginning of a phased reduction of lead in petrol. Patterson still believed the response was too cautious. When he joined a later national panel in 1978, he wrote a 78-page minority report demanding immediate action against lead in petrol, paint, food containers, glazes, and water systems. The regulations tightened slowly. Cars shifted to unleaded fuel. Lead solder disappeared from food cans. By 1996, leaded petrol was banned for on-road vehicles across the United States. The EPA reported that average blood lead levels in American children had fallen by 70% during the phase-out era. That achievement belonged to many people: researchers, doctors, campaigners, legislators, and regulators. But Patterson had supplied something they could not ignore forever: a clean measurement of what the world had been before industry changed it. He began by searching for the age of the Earth. He ended by showing what one human lifetime had done to it. And the contamination that nearly destroyed his experiment became the evidence that changed public health.